Hello everyone, my name is Mathebula. So today we'll be doing a revision for a grade 12 mathematics paper 1. So I've selected 4 questions to assist the grade 12 learners to revise before they are writing their final exams. So the following questions that I've selected falls under the following topics: algebra, number pattern, function, and calculus. So let's first deal with algebra. So here is our algebra. They're saying we must solve for f of x equal to 0 if x is an integer. What is an integer? An integer is a perfect whole number that can be negative or positive, including 0, but except decimal and fractions. So let's check that we find what I've just defined now. So f of o is equal to 0, then we see f of o, we're going to equate to 0. 0 is equals to x cubed minus 4, x squared minus 3 into 3, x minus 1 into x plus 2. So I'm going to equate each pair of brackets with this 0, so then we can able to solve for our x. So we're going to say 0 is equals to x squared minus 3. X is equals to the square root of plus or minus 3, or 3x minus 1 is equals to 0. X is equals to 1 over 3, or x plus 2 is equal to 0. X is equal to minus 2. Therefore, our integer is x is equal to minus 2. So we're coming 1, 2, 1. X is an irrational number. What is a rational number first? A rational number is a number that can be expressed as a fraction, or like a over b, where a and b are integers, but b cannot equal to 0. So we want to check from our x's that we have calculated now. So we have to check which x value can be written as a over b or a fraction. I only see 2. X is equal to 1 over 3. This is a fraction, perfect. Or x is equals to minus 2. Why? Because we can divide it by 1 and it still give us minus 2. So then we're going to 1.2.3. 1.3.3 is a real numbers. If we can check, the square root of 3 is a real number, 1 over 3 is a real number, minus 2 is a real number, which means here they want all the x values. You can say x is equals to plus or minus the square root of 3, or x is equals to 1 over 3, or x is equal to minus 2. So we are done. We are going to 1.2 solve for x, 1.2 solve for x. 1.2.1 we are given, or 1.2 solve for x. Okay, in 1.2.1 we are given negative 15 squared minus 9x plus 4 is equals to 0. So here we have to consider this. We have as a quadratic equation ax squared plus bx plus c. So we need to find a, b, and c from what we are given there. So if you can check, our a is minus 15, our b is minus 9, and our c is 4. So we're going to use this formula for finding our x values: minus b plus or minus the square root of b minus 4a c 2a. So x is equals to minus b. What is b? So let me fix this one so that it can be able to be okay. B is minus 9 plus or minus the square root of minus 9 squared minus 4 minus 15 minus this one is C is 4 and the one is 4 2. What is A is minus 15. So our x, we are going to have two values of x. Our x, why I'm writing this, it's not x but it's x. So our x is going to be a negative 0 0 comma 8 9, or x is equals to, let's punch the calculator, minus 9 plus or minus 2 minus 9 squared minus 4 minus 15 4 little brackets 2 into minus 15. The other one is 0.29. Then we are done. Nothing much. We are going for 1.2.2, which says we should have 3x minus 2x. This 1.2.2 open bracket 3x minus 2 squared greater or equal to x. So what you have to do, you have to factor this out. So we're going to have 3x to the power 2 is 9x squared minus 3x multiplied by 2 is negative 6 multiplied by 2 again is minus 12x plus 4 greater or equal to 3x. So now we have 9x equal to minus 15x plus 4 greater or equal to 0. 3. So now we're factoring out 3x minus 4 minus 1. So we're going to have 3x minus 4 greater equal to 0. Then we're going to have x is equals to, not equal to, x is less or equal to 4 over 3, or x less or equals to 1 over 3. We are done. So we're going for 1.2.3 1.2.3 1.2.3 So we have 5 to the power x is equals to 5 into 4 plus 5 into that. Then here we're going to have 5x is equals to 20 plus 5 times 2 over 5x. If you wanna recall this is a law of exponents. What happens here? These are the law of exponents. So the second step, we're going to let k is equal to 5 to the power x. So we're going to have k on this side is equals to 20 plus 125 over k. Multiply both sides by k, and we are going to have k squared minus 20 k plus, no, it's minus 125 is equal to 0. So now we are going to factor out. So we have k, then the bigger number will take the middle sign. Okay, with the bigger number, okay, we're going to have 25 here minus, and then positive 5 here. So we're going to have k is equals to 25, or k is equals to minus 5. But k is equal to what? 5 to the power x is equals to 25, or 5 to the power x is not equal to minus 5. Yeah, we see that one will never be equal. So one is 25, then we're going to have 5 to the power x is equals to 5 to the power 2. Then for x, therefore x is equals to 2. Simple as that. Yeah, so okay, our answer here is x equal to 2. Ne? So let's check the other solution. The other solution equal to is, it says k is equal to -5. So, and we recall that k is equal to 5 to the exponent of x is equal to -5. So, but we can see that that one is not our solution. It's not equal to x to the power 5 is not equal to -5. We can say, we can make this that is not equal. So this will be our final solution. So let's carry on. Let's carry on. I want to check. Okay, we are going for 1.4. 1.4, it says calculate two numerical values for p so that x squared plus p open bracket 2x plus 7 close bracket plus 8 is a perfect square. Ne? Okay, calculate two numerical values. That one. Okay, let's see what we have here. So we're going to have is 1.4. It says x squared plus p open brackets 2x minus 7 plus 8. So what we're going to do here, take p, multiply the inside. What I'm saying is this comes here and here. So we're going to have x squared plus, okay, it will be 2xp plus, oh no, it's not plus, oh, it's minus 7p plus 8. So from here we have this value, we have this value of x squared plus 2x plus 7p plus 8. So we can see there. So but here we are focusing on the discriminant. We are given the discriminant is equal to b squared minus 4ac. So from the equation, this one, we need to identify which one is b, which one is a, and which one is c. So our c is going to be this one. So our b is going to be this one. So it's 2p. Our b is 2p, not the whole of this, is 2p. So then, and our a will be the coefficient of x squared. So we're going to have this b squared is 1 minus 4 into, oh no, it's not 1 here. I said b is 2p. B is 2p squared minus 4a. What a is 1 and c is 7p plus 8. So we're going to have 4p squared minus 28p 28p minus 32. So we're going to have then we're going to factor this out, guys. So we're going to have p and p minus plus 1 and 8. So therefore p is equals to 8, or p is equal to minus 1. So let's go for the next question, and I think it's question 2, number patterns. So but it won't give us problem. Okay, here is our number pattern. It's written as 2 minus 3 minus 3 minus 2 minus 3 minus 6 minus 11 is a quadratic. They're telling us that this is a quadratic pattern. And a quadratic, what do you know about quadratic pattern? In quadratic pattern, we know that we have the first difference and the second difference. And the first difference of quadratic is arithmetic sequence or series, as arithmetic pattern. And the second difference of quadratic is the constant difference of arithmetic. So let's pay attention to that one because it will help us. So let's see number 1. Say question 2.1. It says determine the expression for the t-nth term of the first difference. Okay, they say the first difference name, and if they say the first difference, I said the first difference is the arithmetic pattern. So we must get tn of arithmetic pattern A and D. So don't worry, I got you. You must okay. It's question 2. Okay, let me write down the series, but in the pattern, the quadratic pattern is minus 3 is 2, minus 2 is 2, not is 2 equal, okay, then we have so here we're going to do this. So this will be our first difference. So we're going to say t2 minus t1. T2 is minus 2 minus t1, which is 1 positive 1. So we're coming minus 2 minus 3 minus 2 is minus 1. So we are coming again minus 6 minus 3 is minus 3 minus 6. Okay, yeah. So then we're going to have minus 11 minus what is the 6, no? Yeah, it's minus 5. So now okay, we can see that we have A. So okay, we need a D, ne? D is equals to t2 minus t1, but of what? Of the first difference here. So we're going to have, what is our t2 here? Is minus 1 minus 1, which give our D's to be minus 2. Therefore we can see that our A is 1. So we can determine our Tn. So Tn is equal to A plus open bracket n minus 1 close bracket multiply by D. Okay, our A is 1 plus n minus 1 close bracket, our D is minus 2. So we're going to have something like this. We take the negative 2 multiply inside the bracket, we have minus 2n plus 2 plus 1, which give us minus 2n plus 3. So this is our Tn. So now we are going to see the following question, but it's 2.2 because this one was 2.1. Yes, this one is 2.1, guys. Sorry for that. This one is 2.1. So I'm going for 2.2. 2.2. Yeah. Okay, 2.2 say calculate the first difference between this term and that term of the quadratic sequence. No? So they need a first difference between which term and which term? 35 term and 36 term of the quadratic sequence. Simple. It's simple. Oh, not here. Here. So we're going to have the Tn that we got in 2.1 is equals to Tn is equal to plus 3. But they need which terms? It's T35. Now we're going to insert 35 here, which is equal to minus 2 into 35 plus close bracket plus 3, which give us what? Minus 2 into 35 plus 3 give us minus 67. So yeah, that's it. It is what it is. So we're going for 2.2.3. Okay, let me check the question. What does it say? 2.2.3. Determine an expression of the nth term of the quadratic sequence. Yes, guys, here we must pay attention so attentively because it's 2.3. Ne? They say they want what? The nth term of quadratic. So they want what? They want Tn is equal to n squared plus bn plus c. Let me fix my square there. They want this. So how? Oh yeah, it's a. Sorry, it's a. Sorry, it's a. So we need to find a. We need to find b and c so that we can determine the Tn of the quadratic. Yeah? So, but we know that a. 2a is equals to d. So our d is the first difference, is the second difference. Our d is the second difference now. So we're going to have we're going to divide both sides by 2. So then a is equals to negative 2 over 2, which give us negative 1. That's a. A is negative 1. I want to write it clearly. It's negative 1. So for b, we're going for 3a plus b is equals to t2 minus t1. So we're going to, okay, we have a. A is equals to negative 1 plus b is equals to, let's go and check t2 minus t1 is what? T2 minus t1 is just 1. T2 minus t1 is 1. So we're going to take that. So we're going to have b is equals to 4. Since 3 is going to be positive, is going to be negative, and then we transpose it, we go that side, it's going to be 4. So we are going for c. To find c, a plus b plus c is equals to t1. What is a? We already have a. What is a? Minus 1 plus 4 plus c is equals to, what is our t1? Let's go back there and check our t1. Our t1 is no, this one. Our t1 is 3. Our t1 is 3. We can check. Okay, let's confirm it from what we hold here. This is our T1. It's minus 3, not 3. It's minus 3. Sorry. It's minus 3. It's minus 3. So we are going to have this, and this is give us minus 3. So we're going to have C is equals to minus 3 is going to give us a positive 3. Okay, minus 4 plus 3 is positive, minus 1 plus 4 is positive 3. Then we transpose that positive 3 to the negative 3 is going to be negative 3. The negative 3 minus negative 3, our C is 6. It's negative 6. Oh, it doesn't want to write. Oh, I don't know why. Okay. C is equals to negative 6. Therefore, the Tn of a quadratic is equals to, our A we said is minus n squared. Our B we said is plus 4n, and our C is minus 6. So this is our Tn. Let me fix here. This is our Tn. So let's check the following question. This was question was 2.3. So which means we're going for 2.4, 2.4, 2.4. Explain why the sequence will never contain where we must explain why this sequence will never contain a positive term. But I think to explain this now we need to prove it by calculations, not by, because maths, maths is numbers, guys. Don't be lazy to solve. Let's try to solve. Don't be lazy. So so far, okay, it's 2.4 now. They want to know why this pattern can never obtain a positive. Okay, we're taking it from Tn is equals to minus n squared plus 4 n minus 6. Okay, let me fix that one. Minus 6. Oh, not a highlighter. A pen. Minus 6. So I'm going to have Tn is equals to minus into n squared. For sure here is the for sure here is the they took out the out the common factor, taking out the negative. They're taking out the negative, then we're going to left with minus 4 n plus 4 minus 4 plus 6. So here we're going to have minus into minus 2 squared minus 2. So this is our pattern. Then yes, our Tn max, we want to know our max, that what will be the maximum of this Tn is negative 2, no positive term. So we'll be done with this question. So we're going on the is this one? Yes, I already prepare it under our last question. So here is question 4. The graph of function is that one. You can see the graph there. You can see question 4 there. The questions are simple and straightforward, because you can see there they say write down a value of p. And p, what is p? Okay, what do you know about this graph? This graph, it has an asymptote. What is this graph contain that has what is the name of the graph that has the asymptote in this problem? is hyperbola. You can tell by the fraction a over x plus p plus q there. So then we have in a straight line h of x is equal to mx plus c. So we can see the point of intersection. You can analyze the graph, can see everything there. So let's dive into the solving. So it's 4. Okay, it's question 4. Oh, not highlight. Question 4. 4.1. So what does it say? It says it needs values of write down a value of p and q. Okay, let's check. What is p? P is found at the denominator of the graph where there's x plus p. We can see then the q. So what is q? A q, if you can recall back there, is the y-intercept. So and the p and a p is not q is y-intercept. We'll be back then for that one. Let's focus on the asymptotes now. Okay, the asymptotes for p. Okay, p will be the vertical asymptote cutting through the horizontal x-axis. P is going to be a -2, but if you can check, is the vertical asymptote, but it cuts through the horizontal x-axis. That's why we take that -2 as x. So which means our P is what? Our P and Q. This thing is simple and straightforward, guys. I just need you to think a little bit before what will be. Okay, if you can see, our x is -2, and I'm telling you that P is the vertical asymptote that touches at the horizontal of the x-axis. So yeah, okay, let me assist you. I think P is 2 and Q is equal to -1. Do you agree with me? Yes, 100%. Okay, this is 4.2. What does the 4.2 says there? What does the 4.2 says there? Let's go back there. Calculate the value of A. Okay, where do we find A? Okay, A is found on the parabola. Okay, so do we have any point on the parabola? Yes. Do we have the asymptote? Yes. So which means we can find K, but man A, not K, the value of A. Okay, I can say A question mark. Say I start. F of x is equals to A over x plus P plus Q. But we already have P and Q. Okay, so we are going to have f of x. Let's substitute P and Q. F of x equals to A over x. What is P? Plus 2 minus 1. You can tell for that one. So now we're going to pick any point on the graph, but not just any point. We're going on the hyperbola. We have -4 there, you can see, and minus 5 over 2. -4 is x, minus 5 over 2 is y. So yes, it's going to be in that way. So we're going to have our point is -4 is to -5 over 2. So we're going to replace f of x by y. We're going to have y is equal to A over x plus 2 minus 1. So we're going to do this. What is y? Is -5 over 2 is equals to A over -4 plus 2 minus 1. What do we do first here? We transpose 1 to the other side. We'll be left with, but you can do your math there. I mean, I can say that, okay, -5 over 2 plus 1 is -3 over 2. Then -3 over 2, we cross multiply, then we get A. Okay, here we're going to get -3 over 2, and it's equals to A over -2. This one is 3. Then we get, so you can, if you can solve here, we see that our A, okay, so our A is going to be 3, because minus 2 times minus 3 is positive 6, 6 is equals to, then 2 times A over 2 over 2, A is equals to 3. So let's go for another question. Determine the equation of the line y of the line of the symmetry of f. Okay, f for m less than 0. Take note of that one. They say m is less than 0. Oh nope, I didn't. M, this one, take note of this one. M is less than 0, which means the gradient is negative, is the negative gradient. So which means we have m is equal to 1 from there. So far, let's go check if we have any point on the graph. For the straight line, yes, we have any point on the graph. If you can check where the asymptote intersect or meets there, that is the point of the straight line. So what point is that? Is minus 2 and minus 1. So let's go and find the equation of h. The equation of h, oh sorry, what is question 1? It's 4.4. Okay, it's 4.4. 4 it's not let me check. Did maybe we're coming for 4.3, right? That was the range. I saw, sorry 4.3. Now we're coming for 4.3. 4.3, let me write it here. 4.3. They want the range. What is the range? What is the range, guys? What is the range? What is the range? Okay, range. Now let's go and analyze the graph before. Okay, the range now. The range of the f is y element of real numbers, but it's not equal to y is not equal to minus 1. Why? Because y is where y is equal to minus 1 is the asymptote. The graph doesn't touch the graph doesn't exist there, in short. So whenever you see the asymptote, know that the graph doesn't exist with this asymptote. So that's why we say our range. That's why we say our range is going to be y element of real numbers, but y is not equal to minus 1. This one is the domain, is the range that the graph can go everywhere it wants, but it must not touch negative 1. So we're going to 4.4. Okay, 4.4 is that one of you have to determine the equation of, what is that graph? Okay, of h of x, or of h of x, but in terms of y is equal to something. Okay, is h of x is equal to mx plus c. But do we have any points? Yes, it's minus and it's 2 minus 1. So okay, and we are told that m is less than 0, so therefore m is equal to minus 1. So we're going to have, they want it in terms of y is equal to something. We're going to have y is equal to minus x plus c. Then we go for the points on the graph. Here is our points on the graph. Okay, so we're going to have y is minus 1 minus into minus 2 plus c. So this minus 2 times minus is positive, then you go to the other side. Minus 2 is positive, then you go to that side, it's going to be negative 1, negative 2, negative 1, negative 2, 2, negative c. Therefore Therefore, C is equals to minus 3. Y is equals to minus x minus 3. This is our equation. That's what they are requesting to us. So we're going to 5.4 or 4.5, not 4.5, sorry. 4.5. 4.5 is 4. Oh, this highlight. Oh, it's okay. What are they saying in there? What are they saying there? Oh, they want write down the asymptote of f of x plus. Okay, let's first check that. What is that for 1 over 2 equal to? Okay, it's equal to 4,5 or 9 over 2, no? So okay, if you can check they have affected x, so which means we are going to take this number and affect the x from the equation that we have. Okay, so which means here we're going to say f of x equals to x plus 4 1 over 2. They want what? Asymptotes. Let me write it down so that I cannot go back to the question. Asymptotes. Okay, asymptotes there. So which means this graph now has been moved 4 over 2 units to the left. So we are going to affect, oh yes, okay, the ones the asymptote, they don't want to show us our workings, so which means we're going to have x is equals to, let me punch calculator here. Okay, the graph, let me check it there on the question paper. It's going to be minus 13,5 minus 13 over 2, not, oh, why do I get these wrong answers? Sorry. It's going to be minus, and the calculator, I have calculator with me where I am, guys, so make sure that you always have your calculator. Then let's check for y. I don't think y they will have any effect. If you can check there, y is going to be minus 1, since they didn't affect y, they only affected x from the f of x. If you can check here, they only affected x, nothing else. So okay, let's go for, I think this was our last question here in this question. So yes, we are done with question 4. So we're going for question 8. Question 8. Okay. Question 8 is state that, we are given that f of x is equals to that one. Okay, determine the first principle, but determine the f of x, but the derivative of x from first principle now. So okay, you know first principle, guys. This is question 8. (8.1) f of x limit h approaches 0 is equals to f of x plus h minus f of x over h. So but what is our f, or what is our f of x? Our f of x, if we can check there from the equation, from the question, we are given our f of x there. Let me check. Our f of x is minus 2x plus 1. Minus 2x is minus 2 x squared plus 1. Okay, so then let's go for this one. Okay, we can see that they have affected x by adding h, so which means f of x plus h plus h is equals to minus 2 into x plus h plus 1. So we can factor this out right now here, which means we're going to have minus 2 into x squared plus 2 x h plus 2xh plus h squared plus 1. So which means I'm going to multiply everything there, which means I'm going to have minus 4x squared minus 4xh minus 2h squared plus 1. So we know that our limit f of x, we know that our limit f of x h approaches 0. Okay, where we see f of x plus h, we're going to substitute this. I think I will need more space now for this problem. Let me extend here. Okay, so I'm going to have minus open bracket. Yeah, it's important to write brackets here, guys. It's important. 4x squared minus 4xh minus 2h squared h squared minus open bracket. Even here, guys, it's important to add brackets. 2 is minus 2 x squared plus 1 close bracket over h. So sorry, here is 2 here. It's 2 here. No, it's not 4. It's 2 here, guys. Sorry. It's 2. Because 2 times, yeah, it's 2 here. So we're going to write equal sign limit h approaches 0. So we're going to have minus x squared minus 4x h minus 2h squared minus multiplied by minus 2x squared going to be give us positive x squared minus multiplied by 1 is going to give us minus 1. So we're going to have something like this. This and this goes away, so we're left with minus 4x minus 2h squared. This plus 1 here, guys. So I forgot plus 1 here. Sorry for that. So this one and this one, they cancel 2. So we're left with these only over h. For those mistakes. Limit h approaches 0. So we're going to take the common factor of h, then we're left with 4x minus 2h over h. This h and this h, they cancel. So we're going to be having something like limit h approaches 0. Oh, sorry. H approaches 0. So we're going to have 4x minus 2h. Let me check if I'm not mistaken. Yes. So, but h approaches 0, then we're going to have f of x is going to be 4x minus 2, 0. When you substitute 0, you no longer write that h approaches 0, guys. You just substitute there. So our final answer will be let me check. I think there was some I left this one from it's only here and here. So our answer here will be negative 4x. So we are going for we are going for 8.1.2. Hence, calculate the gradient of if the x. Okay, the gradient, guys, we're given the f of x there. They want the gradient if x is equal to minus 2, and we know that if we need the gradient is always the first derivative. So and this is the first derivative of x. you see that you already have your answer here, guys. You don't need to go and derivate again because you already derivated there. So we just left to substitute x in our derivation. Only substitute x in our derivation. I was checking that. Which question is that? It's question 8.1.2. 8. Question 4. Crazy. Is 8.1.2. Now they need the gradient. So f of x is equals to 4x. F of x 1 over is 1 over 2. So minus 1 over 2, which is equals to 4 into minus 1 over 2. Calculator, but it's negative 2, you can tell. Now it's positive since this one is minus. Why do I have to leave this minus? Okay, this one is going to be positive 2. Why? Sorry, guys. So 8.2. Determine the derivative of f of x. Okay, and us to determine is 8.2. 8.2 to determine the derivative of f of x. Okay, here it is. It's 8.2. 8.2. Determine the derivative of f of x. What is f of x? We are given f of x as the cube root of x squared plus 1 over 4x to the power 4. Before we derive, and we must first arrange our variables x, what we are derivating. So we are going to have x is going to be 2 over 3 plus x to the power 4 over 4. So I think now we can derive. The derivative will be this one. Here the derivative. This one going to be 2 over 3x, then 2 over 3 minus 1. 2 over 3 minus 1 is minus 1 over 3 plus plus, then here is going to be negative 4 over 4 multiplied by x to the power 5. So we're going to have something like this: 2 over 3x to the power 1 over 3 minus x to the power 5. So this will be our derivative, guys, nothing else. So let's check. 8.3, given that h is equals to that one, h of x is equal to ax squared, a greater than 0, then they're telling us that a is positive. Determine the value of a if it is given that h, or the inverse of h of 8 is equal to the derivative of h is to 4. Okay, let's go and see what they're trying to tell us. These guys here, we have 8.3 now. Let me copy this equation down. Is h of x is equals to ax squared, where squared, where a is greater than 0, which means it's positive now. And what else? Okay, and and what is needed here is a, but where, okay, is equal to this one is the derivative of 4. So here we're going to do this. We can choose. You want to start by the inverse of h or the derivative of h, but let's start by the derivative of h. I think that one is simple. So the derivative of h of x is equals to 2ax. You can see it's 2ax because we are derivating in respect of x, but we are told that x is equals to 4. We are told that x is equals to 4, then we have 2 into 4a, which is 8a. 8a, which is okay. H of a, the inverse or the derivative of h when we're substituting 4 is equal to 8a. So now we're going to find the inverse now. So for the inverse now, I would like to replace f of h of x by y. Okay, which means we're going to have something like this: y is equal to ax squared. Okay, so here it comes the inverse. The inverse name, what is important about the inverse is always swapping the values of x and y. So we are swapping x and y now. So we're going to have x is gonna come this side of y, and y gonna go that side of x. So which means we're going to have x is equals to a over y squared. You heard me correctly. X is equal to a y squared. Okay, then we are solving for y now. We have y is equal to y squared over y is equal to the square root, but this one is y inverse, is h inverse. But we are told that the h inverse, this one is equals to 8. So we're going to have h inverse 8 is equals to the square plus or minus the square root of x. Okay, where there is x, we put 8 now. So then we're going to what we are given there above. They say, oh, this one is the inverse, sorry. This one is inverse. So they say that here it comes. We're going to equate the two, which means we're going to take the the square root of 8 over a is equals to 8a. So to remove this, we square both sides. So we're going to have 8 over a is equals to 64a cubed. It's equal to 64a cubed. It's equals to 64a squared, not cubed. A squared, not cubed. A squared. Oh, okay. Here you can say over 1. Then we cross multiply. Then we're going to have 64 a cube is equals to 8. Then 64 divided by 64 are going to have 8 as then a is equals to 1 over 2, and they said that a is greater than 0, which means they are correct. A is positive. So now I'm going to look on the example I want to give you examples that you'll be looking at. So okay, the first examples will go for these examples will go for algebra, function, and calculus. So one will be algebra. So okay, in algebra you are required to find x to the power x is equals to 2 to the power 10, 4, 8. Yeah, I think it's this one. Then in function you are required to find the x and y intercept of this graph. Y is equals to 2 over x minus 3 plus 1. So then we're going for calculus. For calculus, okay, let me check. For calculus, okay, we are going to derive this now in terms of y, in terms of x. X to the power 5 over 10 plus 1 over 6 to the power 3 of, and what else? Yeah, I think this will be my examples. So you'll be free to comment on the comment section via YouTube, because I'm going to upload this video on YouTube. So you'll be free and allowed to ask any question based on this example and based on an explanation of this revision. So thank you guys. Enjoy the rest of your day and good luck with your exam.